Today we have a 2011 Audi A3, and the complaint with this car is after an engine overhaul was done on it, it cranks but it doesn't start. I was told that the pulley, the crank pulley, was wobbling and then it was thrown out when the owner was driving, and when it was thrown out it threw the chain off and there was piston to valve contact, so that's why the engine overhaul was done. So this has frustrated the garage that I'm in. I'm in a garage. This is not my work. It's a garage that has done the work. I'm here just to do the diagnosis and to guide them on the repair. So they have been frustrated, and you can taste the frustration in this car. So let me show you a couple of things. I can see the rear main seal that's down there, and there is the switch here, which has been removed because this panel is out. I'm not sure why it was removed. I think they were trying to troubleshoot the key, and lots of panels have been out. So before we do anything, let's go to the front of the engine and let's look at it, and then we proceed. So this has a 1.4 liter TFSI engine, and this is the state of the engine now. The reason why I'm showing you this is to show you the difference between engine overhauls that are done well and engine overhauls that are sketchy. What do you see here? Check that out. Okay, and look at this. The reason I'm showing you this, I want to compare this with the work that I do normally on engines. But that's not why we're here. I told them to remove the ECU from the cowl panel, which they have done, and this is the ECU here. I want to do testing on it, but before doing that, I want to show you something. These come with a security bracket, and that is that one here. They come with bolts that you need to cut a slot into to remove. So this is one of them, and you cut the slot and you remove them. Now I don't know what this bracket is for. This bracket is not in the part diagram. It has a part number here, but you can't even buy it even if you wanted to. This is a one-time use bracket. The factory manual does say that if you want to do any service on the ECU, you cut this and throw it away. I suspect they are used for factory warranties to make sure that people haven't tampered with the ECU. But I usually ask the client, do you want to return it or do you want to remove it? I normally remove them. They do nothing other than give you a hard time if you haven't cut that slit on them. And be careful when cutting out that slit. If you don't do it correctly, you're going to damage the connector because this is in close proximity. I've seen people cut right through this connector when using a grinder to cut this. You need to have a steady hand and just be careful. All right, let's go in and we'll see what our strategy is to address a problem like this. So before we do anything else, I just want to verify the complaint. So there is our key on, and let me open the door here slightly. Let's crank it. And as you can hear, it's not even trying to start, but it does sound like it has a healthy crank. Now, depending on where we are with a car, when you're dealing with a no start, I approach it differently. If I'm in a place where they have replaced the engine and they're complaining of a no start, I am always concerned about the timing of the engine. These engines are notorious to time. They take special tools to time them, and if you don't have the special tools or if you don't follow factory procedure, you are likely to time this engine incorrectly. So timing is usually the first place I start when I'm in a garage and it's a no start. So let's go to the wiring diagram and see what we are going to probe for our captures. So here we are in ELSA, And we have identified our vehicle correctly. Now we are going to go to the current flow diagrams, and we're going to look for the engine, which is the CXC from May 2009 because we are 2011. So here we have the current flow diagram. I am looking for the crank sensor. The crank sensor is called the engine speed sensor. And I'm also looking for the cam sensor, which is called the Hall sensor. So here we have the Hall sensor, and it's G40. So let's blow that up. And here we are, G40. It's a 3-wire sensor, and we've got positive supply, a ground, which is negative, and then this is our signal. So it is on T60 pin 53, green and red wire. So we're going to put that on channel A, and then we're going to go to the engine speed sender, G28, which is the crank sensor. So the crank sensor, again, is a 3-wire sensor. Now this doesn't show, but from experience, these are the same type of sensors. So it's pin 2 here, and it is on T60 pin 36, and this is the white and brown wire. Then channel 3, I want to see an ignition coil. So let's go down here. Okay, the ignition coil is on a different diagram. And then I also need to see the injectors. So, oh, the ignition coils are here. So channel 3, we're going to take ignition coil number 1, N70. And I want to look at its control, because I want to verify that we have ignition control. So we're going to take pin 7 of connector T60, and that's the violet and gray wire. And then let's look for an injector. And injectors are here. We're going to take injector number 1. I always reference to number 1, and it'll be easier to deduce stuff from there. All right, injector number 1 is N30. Now, since injector number 1 is on T6031 and T6033, these are piezo injectors, and they are high powered injectors. Normally you'd see activity all the time on both lines, and I just want to see when we see the injector number 1 and not the rest. So instead of taking a voltage, I'm going to take the current of the injector. I can use either of these 2 wires, it doesn't matter which one. So I'll put that on channel 4. 4 channels. Let's go up to the hood and set up our picoscope, and then we are going to proceed. Great tip on how not to mess these connectors. I see people break these all the time. First thing you want to do is dislodge this thing with a fine pick. There is a tab over here, so if you push this tab in like that, you can now pull this out. So it's easier with 2 hands, but you pull that in, like that, and then push it out. Very easy, you don't damage that. Then second thing, how not to damage this one. I see people take screwdrivers, flat screwdrivers, and you pry this out. These are dry. You want to use silicone lubricant, not WD-40. This is just silicone lubricant made by WD-40. Do not use WD-40. I repeat, do not use WD-40. WD-40 will mess the seal that is in here and this thing will give you a problem going in and out because it swells that seal, and it does it very quickly. So you take silicone spray and you spray on the sides over here. So you spray here and on the other side, and then give it some time to soak in. And once you do that, this will come out without struggling. As you can see, I had already sprayed it before. So you'll just pull out and it will not fight you because you want the silicone to go here. Do not put silicone spray or silicone paste on the contacts. This is a disease that many people do. Know that silicone is a resistive compound. So when you put silicone, you are putting resistance on it. So only here around the connector so that it slides in and out easily, and so that your slider goes in and out without breaking it. If you do that, you will never break any of these connectors. For the T60 connector, which is the one we're interested in, that is our lock tab. And what you do is you pull it up like this, and then you slide that cover off. Always look for a lock tab. There'll always be a lock tab. If you're fighting something too much, you're doing something wrong. All right, there are our connections. Channel 1 is the camshaft position sensor. Channel 2 is the crankshaft position sensor. Channel 3 is the ignition coil control for coil number 1. And channel 4, I'm taking the injector current for injector number 1. Now, these Volkswagen ECUs are very easy to probe. Everybody has got a positive and negative. Their ECUs are very nice to probe. You just slip that in and it touches the pin. But because of that, it means that if you exert any pressure, you're going to bend that pin. So be very careful with these when you're probing. We're all set. And another tip for you, Volkswagen do not have a positive cover. They do give you a very generous ECU connection harness for probing, which is something I love about Volkswagen again and Audi. But because of that, if you lay down your ECU on that positive terminal, I don't have to tell you what you will do. You're going to have a very bad day. Not only will you damage this, but you will damage other modules because you're going to send 12 volts down the ground line and it's going to find its way to other modules. You're going to have problems. Just take time and put something here so that you don't have issues. Let's go and set up the Pico inside. And in here, we are going to do a single shot setup. So our channels are ready, but I'm going to come here and do a trigger single shot on channel A, and I'm going to bring it here. And when I start cranking, I'm going to put it on the crank sensor, channel B. I'm assuming we have crank signal. We may not, but we'll see anyway. So when I start cranking, it will draw the waveform. Once it reaches the end, it'll pause it for me, and then I'll save that and then analyze it. So I'm going to put my key in the ignition. I'm going to crank immediately because that line may wake up the ECU and will start my trace. All right, there's my crank. So let me save this first and then we'll analyze it. Okay, let's analyze this capture. First thing I've noticed is that we have everything. So let's section out here. We have ignition, we have injection, we have cam and crank. So this engine basically has everything it needs to run. However, are we in time? These cam and crank captures do nothing unless you have a known good. So what I'm going to do is come to my known good. I have one in my repository for this engine. That's another thing, is make sure whenever you're doing work, have a habit of capturing known goods. So here I am in my repository. Let's go to my engine and reference data, and I have CAXA here, which is the same engine as this one. It's a 1.4 TFSI, and I have a cam and crank correlation known good. Let's open that. I'd taken this with a Handtech back when my picoscope was stolen. So this is our known good. Now let's see what we have. So we're going to section out this almost the same way on the picoscope. So we're going to come here and section here, here, and here. And then I'm going to bring this down so that we can analyze it the same way as on our capture. Actually, let me put it up here like this. And then now let's compare. So here we have a long and a long, and then there's a short section here which goes down, and it coincides with our crank sensor opening there. And look at this. You see the problem? So we have that long and long here. This is the drop, but this is nowhere near here. So we have a massive timing error with this engine right now. How is that, guys? One capture, and we know what's wrong with this engine. This engine is out of time. So what I need to do is to figure out how it is out of time. But before that, I can kind of have an idea of how it's out of time. Is this a timing chain that has been installed incorrectly, or is it something else? The answer is how far away we are in time. So let's bring out our phase rulers here, and we are going to phase out 720 degrees of the crankshaft. So we're going to start here. And this is 360, that is 720 there. Now we're going to bring our measurements. So we know that this is meant to be here. So let's put this here. And let's bring this one where it's meant to be. It's meant to be over here. Somewhere here. And how do you look at this? We are 100 degrees out. We actually advanced by 100 degrees. This engine is never going to start. It's not even going to try and start. But how can we be that far off and yet have the engine crank and we still hear that it has compression, and they've measured compression and they say compression was good? I think there's an issue with the tone wheel of one of these sensors, either the cam or the crank sensor. There is a tone wheel here that is fixed, and that's the cam sensor, and there's a tone wheel here that is not fixed, and that is the crank sensor. This crank sensor tone wheel can be set wrong, and I think that's what has happened here. So let me show you what I mean. Let's go to the parts diagram. We're here in our parts diagram. We go to the engine. And we're going to look for the rear main seal. Yeah. Okay. So here we are. That's your rear main seal, number 19. Sealing flange with sealing ring and trigger wheel. You see that? Let's open this, and I want you to look at the photo. Look at this. Let me zoom in here. You see this trigger wheel? This sealing ring has got your crank sensor trigger wheel, and your crank sensor sits right in here. I can bet you during the installation in this engine, these guys did not follow the factory procedure for putting this trigger wheel in place. Actually, the rear main seal. You're supposed to buy a new one, and it's supposed to come with a lock tab, which is this blue thing here. That's the lock tab. You're not supposed to remove this lock tab until you embed this whole thing in your tool. Then you use the tool to press it onto the crankshaft. And then you remove that piece of plastic over there. That is the only way you're going to get this thing set correctly. So let me tell them to remove the gearbox, and we're going to do it now. I don't have that tool. That tool is wicked expensive, and it's not worth buying. It's more than $200, and you're only going to use it to install a seal. No. So I'm going to show you a process which I use, and it is very accurate. All right, gearbox is out. This seal, that dot is meant to be up here. There is a tone wheel tooth here that's supposed to align with this mark here. So we're going to remove that and align it properly and put this thing back. So on the bench, this is your seal. What you need to make sure is this Teflon part faces inwards. So when you put this on the crankshaft, put it without the tone ring. So put the tone ring aside, put this one in, and this should face inside. So the crankshaft should ride with this seal facing inside. If it faces outwards, it will leak. So you use a pick, push this in, and then put it in. And then you are going to, it has its own seal over here, so you don't need to put sealant really. You're going to put your screws, and you're going to put sealant at the bottom and seal the oil pan. Then for your tone ring, this dot here has got that tooth. That tooth aligns with this mark on your seal. So let me mark it. That's the mark. So that mark goes with that tooth. And then it's pressed in a certain number of millimeters. I'll look in the service manual and I'll put it up here. And you just tap it in, make sure it is even, and you're done. No special tools needed. So that's a view from the top, and those are your two alignment marks. That tooth with the mark. So the hole is going to be just slightly offset from the top one, and now that tone wheel is aligned. Alright, the gearbox has been put back in, and we are taking our captures again exactly the same as last time. So let's go in and take a look at what the picoscope will give us. Alright, let's open our previous file. And the beauty of the picoscope is when you open your file, all your settings are loaded onto the scope, and all you need to do is to hit run and you're good to go. Okay, there's our capture. Let's hit run. and we are running. Now let's come here to our ignition and we are going to start the car. So there we go, the car is running. We have a bit of a misfire, but that is not what I'm here to solve. I was here to solve a no start, which we are running now. So let's pause. Oh, it's already paused. So let me first save this. Now let's analyze that. And now we can see that our two high long pulses have this, and that is falling exactly where it needs to be. So let me section this off like that, and you can see you got the two highs, and that dip is falling on the opening. So we have got the timing exactly correct, and now this engine is happy. So now, final thoughts on this. How could this be avoided? Simply by the garage following factory information. Without factory information, you're never going to do a good repair. It is something I'm trying to teach people to learn to do, is get the factory information. You're going to have quality repairs and you're going to avoid stuff like this. So the other question is, if you noticed on the engine, you saw a couple of oil leaks here and there and things that were not done very well. What am I going to do about that? The answer is nothing. You've got to learn the subtle art of minding your own damn business. I was here to do one thing and one thing alone. The car was not starting, and I was here to diagnose the no start and to help them repair the no start condition. That's my work. I'm not even going to scan this car for codes. I don't care what codes it has. Anything else after this, they will address themselves. And if they have a problem that they cannot fix, they will call me to address. I don't tell garages how to run their stuff. I don't care what they do. I do my work differently, but that's my work. If this engine was being done at my place, we would use all OEM stuff. You would not see all those sealants that was being put in the engine, and this engine would be very clean. Everyone does things differently. This is why I tell people, choose who you take your car to. If you want service that is very good, you need to pay for it. If you want service that is surface, then that's what you'll get. It's all up to you as a customer in the long run. But as for me, I've done what has brought me here, and my job has been successful. So that 2011 Audi A3 is in the bag. Another one for the books. We have something interesting on the next bay, hopefully, and we'll see you next time for that one.